Okay, right. Now we have been able so far to derive the general solution to the wave equation, and also we've been able to derive the D'Alembert's formula for solving the wave equation. Now let's look at some example to solve a wave equation using the D'Alembert's formula. And you realize once you have a formula, it's one of the easiest way of solving any equation, because any problem, because with the formula you just plug in the variables in that particular formula and you have obtained your solution. Now in this case we've already derived the D'Alembert's formula. You will realize it's very easy to now solve when you have the D'Alembert's formula. For example, now we are to use the D'Alembert's formula to solve this initial value problem. UTT is equals to c squared uxx. That's wave equation, with the initial position u of x0 to be equal to f of x, which is cos x, and the initial velocity ut of x0 to be equal to 0. Now in this particular case, now let's write the D'Alembert's formula. Here is the D'Alembert's formula. U of x t is equals to 1 over 2 f of x plus ct plus f of x minus ct plus 1 over 2c x integral from x minus ct to x plus ct of g small g of s ds. Now we know very well f of x is cos x. Now we can replace here with cos x. We have 1 over 2 cos x plus ct plus cos x minus ct for the initial position, and the initial velocity is 0. So this particular term over here will disappear. Everything becomes 0 because integral of 0 makes everything 0. Okay, so now in this particular case our solution will be a half cos x plus ct plus 1 over 2 cos x minus ct. So I think there is supposed to be a ct at this particular point. And also this we are supposed to have x minus ct at this point, not unless you are told, like let's say c is equal to 1, then you will replace it, or c can be any number. This c stands, c can be any number because the square of c in this particular thing gives you the velocity, so they can give you anything for c. Now let's look at another example. Now let's use the D'Alembert's formula to solve this example. UTT is equals to c squared uxx with the initial position to be 0. Now u of x0 is equal to 0, and initial velocity ut of x0 is equals to sine of x. Now our solution, we first, since we are to use the D'Alembert's formula, we just start by writing the D'Alembert's formula as it is, and now plug in whatever we have into the formula. Now f of x is 0. Everything in the first component will be 0, plus 1 over 2c integral of x minus ct, integral from x minus ct to x plus ct g of s ds, of which we'll have integral 1 over 2c integral from x minus ct to x plus ct sine of s ds, and when we integrate that, integral of sine of s is negative cosine of s, so we'll have 1 over 2c negative cosine of x from x minus ct to x plus ct, and when we replace x minus ct and x plus ct in there, we obtain 1 over 2c cos x plus ct minus cos x minus ct to be a solution to this particular wave equation. And this is how easy the D'Alembert's formula is in solving the wave equation. So in most cases, somebody might not just tell you to use the D'Alembert's formula. The person might ask you first to derive the D'Alembert's formula. Then the question that follows will be, now use the D'Alembert's formula to solve this and this. And he will have given you the values of all these things, like maybe give you a value of c. Unfortunately, here we are just using c as it is. C, they can give you a constant for c or any value for c, and then you will have to replace everything and solve to obtain the solution. So this is how we use the D'Alembert's formula to solve the wave equation. Okay, so thank you so much for listening to me, and we'll look for more examples to solve, and also I'll give you some more work on the same to solve, and you'll have to submit the work to my email. And I don't think there's any need of typing, because you will get a real assignment that you'll have to type. So I want to save you the time to type so that you can study and do other things, but you can snap it properly and send the PDF of it to me, and then I'll look at what you will have done. So this assignment is whatever questions and quizzes I'm giving you, they're coming from me. Your lecturer will prepare an assignment that covers everything and send it to you through your TS. Okay, thank you so much, and I wish you all the best as you revise, and also remember to wash your hands, sanitize your hands, keep a distance of 1 meter away from people when you are interacting out there, and stay indoors. Don't go out. And I wish you a safe stay at home, and see you after the pandemic.